Hi, welcome to the Calculus 3 and assignment practice series. And we are in this unit of vector calculus. So today we're going to take a look at the homework assignment number 6, which is about the green theory. So we're going to work several problems on the assignment sheets so to help and try to help you to get a good start, and hopefully it will be helpful for you to finish the assignments here. Okay, so now let's go to the assignment worksheets here. Okay, so let's take a look here. So the first ones here, it asks you to, evaluate the line integral. You can directly, that means you do the parametric, or you use the green series here, all right? So let's take a look at the first ones here. I'm going to take a look, it's the number 2 here. So then the number 2 here, so let's say I'm trying to integrate this line integrals over these circles here with radius is 4. And because of this notation, that means we know it's going the counterclockwise, right? So the curve go like this way, see here. Okay, so now let's go ahead and start with the parametrics. Okay, so parametrics here, the first here I say x is equal to, because this is radius 4, so we typically is r cosine theta, right? So this is the easy ones here. So we said cosine. So if you want, you can say t. Then what is the here? We say y is equal to the 4 sine t. See here. Then the dx here is will be negative 4 sine t dt, right? Then the dy will be equal to the 4 cosine t dt. Okay, so the direct method, that means we use parametric and so change everything to one single variable. So here, this is the c. So this is the y dx minus x dy. So it's just like we start this unit here. So y, this is the 4 sine t dx, all right, times negative 4 sine t. Okay, so the now plus minus x here, this is a 4 cosine t dy, so it's 4 cosine t, right? So times another 4 cosine t, then the whole thing's here is dt's here, right? So what is the t here? From 0 to 2 pi here, okay? So now let's take a look here. So this is 0 to 2 pi. So this is 4 and 4. So it's what is negative 16 sine square t. 4 is negative 16 cosine square t dt. Well, this one turns out to be very beautiful. So if I get a negative 16 out, so this is 0 to 2 pi. So this will be the sine square t plus the cosine square t. Whoa, dt. So what is the sine square t plus cosine square t? This is 1, right? So this ones here, that will give you negative 16, 0 to the 2 pi. This is 1 dt. So what is here? Negative 32 pi, right? Because, all right, so this is negative. So this is by the parametric direct way. Okay, so now let's take a look by the green methods here, right? So green, so this is what? This is my pxy, this is my qxy here, right? So my pxy is equal to y, my qxy equal to what? Equal to x, right? So now rho p, rho y, what you have is here, rho p, rho y will give you rho p, rho y is give you negative 1, I'll give you 1. Rho q, rho x, I'm sorry, the rho x next one, rho q, rho x, this is negative 1, all right? Okay, so by the green series here, right? So we say this is y dx minus x dy. This one will be equal to your integrating over the circles, right? So it's rho x rho q minus rho p rho y. So it's minus minus, then it's over this area. So what is here? So this is a negative 2 over this area. So here, dA. So that means we are integrating these areas, right? So I know this is the circle. So what is the circles here? This is 2. So pi r square. So pi r square. What I have is the same way. So it's negative 32 pi. So, you know, when you use the parametric or you use the green, so these ones here, I think both methods kind of the pretty easy, right? So green is maybe a little bit easier, but it's pretty similar. Okay, so now the next province here, I want to take a look, is number 6 here. C is the triangle, okay? And so here, so C is a triangle from the 0, 0 to 2, 1, then to 0, 1. See here, okay? So that means I'm start from here, here, and here, right? Okay, so because I started, so this will be the positive orientations, right? So go down here, go here, and go here, right? Okay, so for these ones here, I definitely I don't want to use the parametric way because then you need to do the parametric for 1 line, 2 lines, 3 lines, right? So you're going to do the parametric for 3 lines. That's probably is pretty tedious. Okay, so now let's take a look at here. So let's try to use the green. So pxy is equal to the x squared plus y squared. All right. Then the qxy is equal to the x squared minus y squared. So the rho p, rho y is equal to what? It's 2y's, right? Then rho q, rho x is equal to what? It's 2x. Okay, so the whole distance here, so will become what is here? Rho q minus rho p, right? So it's a 2x minus 2y, correct? Over the d, then you do the dA. You want to integrating these regions here, right? So you want to integrate in this region. Okay, so I know these lines here, right? So this one, this is a y, so this is y equal to 2x, right? So this is y equal to 2x. Okay, so now you can change this is back to the what we learned in the calculus 2s here. You say, okay, I'm integrating 2x to y. You can do the dx first or the dy first. Oh, this is sorry here, this is not y equal to the 2x, it's y equal to what? X over 2, that's right, I need to be careful. Okay, so now you can do, you know, either integrate the x first or y first. So let's take a look, I'm doing the dx first, right? That's fine, so I'm doing the dx. That means what? This boundary, I need to put an x here. So look, the x is this way, right? So where do I do here? I integrate from 0. So here, this will give you x equal to the 2y's, right? So I integrate from 0 to 2y. Then after you finish integrate x, you just integrate the y out. So it will be 0, 1. Oh, right? Okay, so now if you integrate here, so this will be the 0, 1. And it will give you the, so you integrated this one out and then substitute, so you will get this is 4y squared minus 4y. Oh, this is a 4y squared minus 4y squared. Then the dy. Whoa, what I have here, I have a what? I have a zeros here, right? So here, this is will give me the zeros here, right? Okay, so 4y minus 4y here. Okay, so will give me 0. Wow, that's interesting. All right, okay. So that is the what is the number 6 here. So then the next ones here, I'm going to do number 9 here, right? Okay, so number 9 here is the same way. I'm going to use the green series, right? Okay, so here, let's take a look. Let's say that I'm integrating over this circle. This is x squared plus y squared, right? Now it's 4, so radius is 2. Okay, now let's take a look here. So this is what? This is my P, this is my Q here, right? Okay, so let's take a look here. So the PXY equal to YQ, and so rho P rho Y is equal to the 3Y squared. Correct, right? Okay. Then QXY is equal to negative X cubed. Then rho Q rho X is equal to what? Negative 3x squared. All right. So now this integration C, right? Okay. So then this integration cy fourth dx plus 2xy3 dy, it will be equal to rho q minus rho y, rho p, right? So it's negative 3x squared minus 3y squared over the d and this area, right? So this is d areas here. Okay, so now, okay, let's take a look. That means it's inside this circle area. So, okay, so now in here, you can, so what you can do is here, so this will be, okay, so you take the 3 out, so this will be the d, this is x squared plus y squared, correct? Okay, now the dA. So now in here, you know you want to integrating over this area. So what I can do is here, I need to do a polar transformations, right? So I can say x equal to r cosine theta, y equal to the r sine theta, right? Okay, so if I do that, and then the disintegration will just be equal to what? Negative 3 and r squared, right? So x squared plus y squared is what? So this one here is x squared plus y squared. This is r squares, right? So this is r squares here. Sorry, here I should say this is the x equal to the r cosine, y equal to the r sine here, right? Okay. So now this is r. So this is x squared plus y squared is r squared. So this is r squared. And don't forget what? Jacobian. So it's r. Then the dr d theta. Right? So what is r? From 0 to 2. And what is the theta? From 0 to 2 pi. All right. So now the answer is pretty simple. You can just integrate that out. And the final answer will be negative 24 pi here. Okay, so we try to do two more problems here. So so for this problems here, so f of xy is equal to the y cosine x, and it's pretty complicated. C is the triangle. Okay, let's see here. Okay, so C is a triangle from 0, 0 to 1, 2, 3, 4, from 0 to 4, for 1, 2 to 2, 0, and then back here. Okay, so this is my triangles here, right? Okay, so remember, let's say from 0, 0 to 0 to 4. So you go this direction, right? So it's from 0, 0 to oh, my triangle is not right. I mix up the x and y's here. Okay, let's try again. All right, so here. 1, 2, 3, 4, 1, 2, 3, 4. Okay, 0, 0 to 0, 4 here. Okay, and then 0, 4 to 2 zeros here. All right, much better. All right, so that means this is my triangles here. Okay, so the way they say it, let's take a look at the orientation. 0, 0 to 0, 4. So I'm going this way, right? Okay, then 0, 4 to 2, 0. I'm go down this way and then go back here. Okay, so I'm looking for, so the C is this direction. So it's negative, right? So it's negative orientation. So I'm trying to looking for the C, the F of what? DRs here. Okay, so that means in here, this is the one, just like, you know, in the Calc2, when you integrate AB, F of X, dx, right? So if you change this to the BA, F of X dx, what happened? You have a negative sign. You switch the you know, the starting and ending point. So just like in here, this is negative orientations, right? So in order to use the green theory, we need to have the positive the orientation. So that means I'm going to have a negative, and then this is a negative C here for the F of dr, right? So then the negative C is go backward here, right? All right, so now let's see here. This is my PXY, and this is my QXY, so here, right? Okay, so now let's use a green series. So the PXY is here. So rho P, rho Y. Okay, rho P, rho Y. So it's a cosine X. Oh, this one is a pretty complicated. Rho Y, so change the product rule. So it's X sine X here. Then, okay, so X, Y sine. Okay, so that's it, right? So for the X sine X. Okay, now, okay, so this is rho P. So rho Q, rho X is here. Rho Q, rho X is Y, right? Okay, Y plus, all right, so this is Y plus rho X is here, rho Q, rho X. So it's X, Y, and this is a product rule. So plus cosine X minus X sine X. All right. Okay, so now this integration going to be integrated over this region. Now rho Q, rho X minus rho P, rho Y. So it's Y plus cosine X minus X sine X minus rho P, rho Y. So cosine X minus X sine X, right? Okay, and the name is dAs here. So let's see here. This one's here. This is y plus cosine x minus x sine x minus cosine x plus x sine x dA. Oh, much better. This one's here. This one cancel cosine. Oh, beautiful, right? So it will be, okay. So this will be, I change to this one's over D, and okay, so this one over D, okay, don't forget, I will have this negative sign still in front of us. Don't forget that negative sign. So I change it for Y, dA. Okay, so now you can decide here, this is y, you want to do dy dx or dx dy. So let's try to do dy dx first here. So this is a triangle here. Okay, so that means you integrate what? You integrate the y first. So from here, go up, right? Okay, so what is this lines here? This line, I can write is y equal to the 4 minus x. Okay, so if you want to integrate the y, so it's from 0 to what? 4 minus 2x, all right? And then the x is from where to where? From 0 to 2. So now we change the integration to a very easy one. So now the answers here, final answer is negative 16/3. Okay, so the purpose for this problem is want to show you when your orientations is clockwise, that means, so this orientation we said is negative orientations, right? So if it's negative orientations, what you need to do, don't forget you need to have negative signs, right? So just like we did for the calculus 2, if you switch the integration bound, it will be the negatives here. Okay, so now let's take a look at the last one. This one's here. This one is a very interesting one also. So let's say C consists of the arc of the y equal to the cosine x from -pi/2 to 0, and then to pi/2 to 0, and the line segments. Okay, oh wow, let's take a look here. Okay, so this is a pi/2. This is a -pi/2. Okay, so let's say C is the curve y equal to cosine x from pi/2 to 0. We know cosine 0 is what? It's 1, right? Okay, so it's go from here. So it's cosine -pi/2 here to the pi2/0 here. And the line segments, okay, so it means from this point to here point, okay? And then, so it's a conserve the y equal to cosine from the -pi/2 to 0 to pi/2 to 0. See here, cosine pi/2. Yeah, so this is the, okay, so end of the line segment, pi/2. Okay, so that's why this curve go like this, right? Okay, so let's try to write it. So from this curve, go to here, then go down here, then the segments here from pi/2 0 to where? To here, right? Because when the cosine pi/2 y, the y is equal to, the zeros, right? So that's the cosine, right? So you need to passing through the ones here, right? So cosine 0 is 1. Okay, so let's see here. Okay, so that's good. After we know the path, so this is what? This is the counterclock. This is the, this is the clockwise. So this way we need to have another negatives here, right? So here, this is the pxy. This is a qxy. Okay, so let's write it. So we said C, the FDR, has to be the negative sign when you use the counterclockwise. So it's negative C FDR. Now, because the negative C is going to the positive orientation, so you can use the green series, all right? So now the PXY, rho P, rho Y, let's see what is here. Rho P, rho Y is 2 Y's, right? Okay, then the rho Q, XY, rho X, rho Q, rho X is equal to 2X, okay? So this is by the green series, right? So this is by the green series. So this one will be equal to negative and negative over these regions, right? Over these regions. And rho Q minus rho Y. So it's rho X, 2X minus 2Y integrating over this region. Okay, so we are integrating these regions here. So now, just like we did before, so this is, you can change, this is 2x minus 2y. You can change it to the dy dx or dx dy. Okay, so the dy dx, I'm integrating y first, right? So I'm going like this way. So what is the bound here from the 0 to what is this curve? This curve is cosine x. Then what is the x bound? pi. It's negative pi over 2 to what? It's pi over 2. Haha, so in here, the answers here is 1/2 pi. Wow, that's pretty cool, right? Okay, so it's 1/2 pi here. Okay, that's it. So the last two problems I just want to show you, be very careful. If the path is negative orientation, then you need to add a negative sign in front, right? Just like the calculus 2, you switch the integration limits, you need to add the negative sign. And after you add the negative sign, then you can apply the green series, right? So remember the green series, you need to have positive orientations there. All right, that's it. And I hope the problem we did here can help you to finish this assignment a little bit easier. All right, that's it. And looking forward to talk to you in our next video. Okay, bye.